Hi everyone, it's Sorkin. Today we have a problem when we are given a courses and also we are given a prerequisite for each course. So for example, in this case, we are given a two courses, 0 and 1, right? And also we are given a prerequisites. So prerequisite for the course 1 is 0, and in our case we need to return the order in which we are going to take those courses. So for example, in this case, since the prerequisite for 1 is 0, first we are taking a 0 course, then we are taking a course 1. The way we are going to solve this problem, we are going to represent our courses in a graph and we are going to apply topological sort to the graph. So for example, let's take an example. Let's take we have 4 courses and we have 1. So for the prerequisite for the 0 is 1 and 2, prerequisite for 1 is 3, and prerequisite for 2 is 3. Let's represent that in form of a graph. Let's say that we have 0, which depends, so which means that which has the prerequisite of 1, right? Also 0 has the prerequisite of 2, and the 2 has prerequisite of 3, and 1 has prerequisite of 3, and 2 also has the prerequisite of 3. So how we are implementing our topological sort? In the topological sort, we are starting from our node, in our case this 0, right? And we are deep first searching. We are deep first searching and finding the node that does not have any dependency, and we are adding that to our result. Let's put our result here, right? So we are deep first searching, and first we are going to, let's say that we are starting from the first one, right? First, does it has any dependency? Does it has any prerequisite? Yes, it's 3. So let's go to 3. And does 3 has any dependency, any prerequisite? No, it does not. So we are adding 3 to our result first. So besides that, we are also maintaining two variables. One is array of Boolean, right? Array of Boolean, let's call it a stack. And another one is array of Boolean again, and it is visited. So which nodes we have visited, right? So in this case, we have only 4 nodes, right? We have only 4 nodes, but let's say that we have 50, 100, and so on. If we visited that node, we should not visit that again. So first we are visiting, in this case, 0 node, right? So let's put another color. So first we are visiting the 0 node, then we are visiting the first node, then we are visiting third node, right? And also we are maintaining our stack. Why? Because we need to, in case if we have cycle, in that case we cannot complete our courses, right? So first finish this one. So we are adding to our stack 0, 1, and 3, right? We are adding to our stack 0, 1, and 3. So we have completed this part. So we are here. Now we are backtracking, right? So we deep first search this branch. Now we are backtracking. So we are adding 1 to our result also. We are adding 1 to our result. And now we are exploring deep first searching this part, right? So as we are deep first searching, we are removing from our stack these values, right? We are removing from our stack these values. So we are adding 2 is 2 visited? No, 2 is not visited. Thus 2 has any dependency? Yes, it's 3. And 3 is already visited. So we are adding 2 also to our result. And the last one that we are adding to our result is 0, right? 0. So this is the sequence in which we are going to return, starting from 0. First we are starting from 3. First we are taking the third course, then we are taking first one, then we are taking second one, and the last one we are taking the 0. Okay, so let's take one more scenario. Let's say that in order to take the course 3, we also need to take the course, so for the 3, right? So for the 3, let's say we have the prerequisite of 0, right? Prerequisite of 0. So what's going to happen in that case? In that case, once we are deep first searching, right? Why we are maintaining this stack? So let's say that we are starting from 0, then we are adding 1. So we are deep first searching, right? we are deep first searching and we try to find a node that does not have any prerequisite. So we are adding that to our stack 1, then we are adding 3, right? Then we are again adding 0, try to again add 0. At that point, we can say that, okay, this is cyclic. This is a cyclic graph, and we cannot finish courses, right? At this point, if we are trying to add the same node to our stack again, so at this point we are going to return empty array, or in our case we're returning empty array, which means that we cannot finish this course. And as you can see from here, it's a cycle, right? So in order to finish 0, so in order to take the first course, we need to take 1 and 2, and in order to take the 1 and 2, we need to take 3, and in order to take 3, we need to take 0. So it's a cyclic graph, so we cannot finish our courses. Okay, let's take a look at our implementation. So what we are doing here first thing that we are doing, we are creating a graph which is array of lists. So first we are creating an empty array list for each prerequisite, and then we are populating the values. So we are adding here for example the index 0, right? Let's say index 0 is the 0 course. So this course 0, it's prerequisite to what? It's prerequisite to 1 and the 2. So for the 0 index, we are going to add the list of array list with the values of 1 and 2, which means that the courses 1 and the 2. So after we completed our graph, now what the next thing is, we are creating array of Boolean visited, where we are going to mark each node that we visit, and also we are creating a Boolean stack that will help us to maintain a stack as we deep first search our graph. So the next one is we are creating a result where we are going to store our values and we are going to return. The next one, for each value, for each node, we are going to deep first search and find the first course that does not have any prerequisite. So in our case, we are calling it a has cycle, because at the same time also we are looking for cycle. We are deep first searching and we are looking for cycle. If we find a cycle, doesn't matter in which node, it means that we cannot finish courses. So let's take a look at our has cycle method. And in our has cycle method or function, so what we do here, first thing is we are checking that if we have that node in our stack, right? So it's our DFS. At the same time, we are looking for the cycle. If we have in our stack that node, what it means that we have a cycle already. So we are returning true. If another one is that if we have already visited that node, we are returning false here. And after that, if we are just adding that to our stack and we haven't that visited, so we are marking both as true, and we are recursively calling. So for example, in this case, let's say that we are starting from the 0, right? We are starting from the 0. And so the prerequisite for 0 is prerequisite for 1 and the 2. So we are going and exploring, calling them recursively. So first we are exploring first, right? And calling recursively, passing here 1 and passing here our graph visited and the result. And so if we find the cycle, then in that case again we are returning true. If we are not, so what we do next? The next one is we are adding that to our result. We are adding always to 0 index because we want to maintain the order. First we are going to add the 3, then we are going to add 1, right? Then we are going to add 2, and at last we are going to add 0. In our example, 0, 1, 2, 3 courses. So and also as we are backtracking, right? We are marking in our stack. So we are marking it as a false, because we are going to use in another branch of our graph also. So that's our has cycle method. And as we exit this loop, right, we have deep first search for every course. So what we are doing, we have a result, but we need to return our result in form of the array, not the array list. So we are forming here our array and returning our result. So that's it for the explanation part. How about the time and space complexity of this solution? The time complexity is that the first thing is, for the time complexity is determined by our these three for loops, right? So we are first forming our graph, which is that let's say that the number size of the prerequisite of p, right, of p. And also we are deep first searching every node, right? So we are not visiting the one node second time because we are maintaining visited array of Boolean. So it's a O of, let's say, n, right? N being is the number of the nodes, O of n. So our final time complexity is n plus p, right? N being as the number of the nodes and the p is being the prerequisite. So how about the space complexity? Space complexity is determined, we have these four data structures here, right? We have the list of, we have graph, we have visited, and we have stack, and we have result. These three are the sizes of O of n because the size number of courses, right? And the forming a graph is the size of the graph is the size of n plus p because number of courses and the number of the n being the number of courses and p is being the number of prerequisites, right? So it's also O of n plus p. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time and bye.